Hello everybody. Today we're going to take on the topic of quadratic functions and using the graphing calculator to do that. I always provide this lesson, it's a single lesson here, after we finish chapter 6 because you need to know how to do all of these things with a pencil. Graphing calculator is not the magic bullet to answer all your questions, but it does provide a lot of shortcuts and a good way to do problems with quadratics and any kind of problem that if you know what you're doing here. So we're going to take on quadratic functions using the graphing calculator. All right. Well, I've listed 4 things here that they're going to be on your test, and the 4 things we're going to cover today on using your graphing calculator. The foundation for all of this stuff we've done in the past. Now there are some steps that are printed for you on a worksheet out in Canvas. If you go to this lesson out in Canvas, there's a worksheet out there. You click on it, and print it. You can use it. You can even bring it to the test if you need to. But these are the similar steps for some of the stuff we did clear back to chapter 2. So on that worksheet, you're going to get everything from chapter 2 all the way up to present that you can use to help you solve some of these situations using the graphing calculator. So what are we going to do here? Well, we're going to find the max and the min of quadratics. And here's a couple parabolas. Of course, the maximum is that spot at the top, the vertex up at the top. And the min is that vertex if the parabola opens down or opens up. So the max would be this one, and the min, this is your max. And this is your min, depending on which way the parabola opens. Now remember that if your parabola opens down, that's where A is some negative, and where the parabola opens up, that's where A is some positive value. That'll help you find, we can help you find the vertex, the maxes, and the mins. Then we're going to spend some time talking about finding the zeros, and the zeros are those spots where the parabola crosses the x-axis. We're going to do that with a function on the calculator. And then we're going to spend most of the time here talking about plotting data and finding points on the quadratic. And we're going to give you a table full of data, whole table full of data, and you're going to put that into your data table. And then finally we're going to show you how to find complex roots using the quadratic formula. The quadratic formula is necessary here because complex roots are not real, and they don't appear on the graph. They are there, but they are not visible on the graph, so you can't use the graphing calculator to do that. And I'll go over all of those things. Let's start with number 1, how to find the max and the min. All right, we're going to begin by taking a look at how to find the max or the min. Now, of course, the maximum is where the parabola opens up, and it's going to be a spot at the top. And the minimum is that spot where if the parabola opens up, it's that spot at the bottom. Both of those are the vertex. Let's take a look at this equation. I'm going to enter this in the calculator, but before I do, I want you to notice that this is actually a formula for calculating the fall of gravity. Remember our number -16, and I could probably change this to t here, t squared, t standing for time. And what we've got is a graph where time is being compared to the height or the altitude. We could probably change this to h of t here. And we're going to put this in the calculator, and what we're going to do is we're going to calculate that spot where the parabola goes the highest. This is the vertex here. So if the question asks us something like, well, where is the highest, the maximum height on this object that was hurled into the air, we can find it right here at the vertex. Now we could do that using x equals -b over 2a to find the x value. Find that x value, but we can also then plug it in to find the y value here. So we can calculate that vertex, and we're going to do that simply with the calculator. So I'm going to go ahead and stick that into the calculator here. Alright, I've gone ahead and put that in the y equals screen in my calculator. By the way, if you recall, this 80 is the velocity, the initial velocity of an object thrown up in the air, positive meaning up. And this 6 is the initial height of that object when it's hurled into the air. And you can see from my picture here that the initial height would be here at 6. And then it was hurled up into the air at a velocity of 80 feet per second. And 16 is a number that always applies to gravity on the Earth. So there's your function, and we're going to go ahead and find the maximum. Before we do that, let's just see what this looks like on the graph. We'll hit graph here. And I don't see anything. Let's go ahead and change our window here. Okay, I'm going to go zoom standard and see what happens. Okay, I get a parabola here, it looks like, but I can't see much of it. So let's change the window, and I'm going to change it so that my x minimum is like, just goes to a -2. And I'm going to have to change the maximum because it looks like my parabola went off the top here on the y. So let's go up to 100 feet in the air and graph it again. Oh, it's going higher than 100 feet. We're going to have to change the window again. So I'm going to window. Let's make it 130 feet. 130 feet, okay? And also, I want to change the scale on my y scale so that it goes by tens instead, okay? There we go. Alright, now I got a parabola here, and you can see down at the bottom corner here that it's about 6 is where it leaves, and then the parabola goes up and comes back down. Now what we want to find is the vertex, that spot at which the parabola is the highest. And to do that, we're going to use the second calc button, which is on the top row here. It's this top row, it's this button right here. So I'm going to go second calc, and I want to find the maximum, which is at the top. Now if the parabola opened up, then I would use the minimum, but we're going to go the maximum for. And then it's asking us questions at the bottom, and so we're going to follow those questions. Left bound, in other words, I want to take my cursor, and I'm using my arrows here, using all my arrows to move the cursor to the left of the vertex. So there it's now just to the left, anywhere to the left of it, okay. And then I'm going to hit enter, and now it's asking me for the right bound. So I'm going to move my cursor over to the right side of the vertex, hit enter again, and then it says guess, but I don't know quite why that's even in the calculator because I've never used it. Just ignore that and hit enter one more time. And when you do, the cursor now is popping right at the vertex. And you can see down at the bottom here that there is some numbers. Now, what's really interesting here as we do this is realizing that the maximum x, the x value, the vertex, is found at 2.5 and 106. Some of you are looking at this number and you're going, huh, why is there a 4 at the end? Well, your calculator is looking for that spot, and it is kind of estimating a little bit. But all of these zeros here is an indicator that this is actually 2.5 exactly. Now, those zeros are just kind of an indicator, oh, this really has just been looking for that spot. You might see the same thing happen if it was like 2.499999995 or something. All those nines or all those zeros are telling you, oh, this thing is actually 2.5 exactly. So my ordered pair is at 2.5 and 106. Now what it's telling me is that this point, this vertex of my parabola, is at 2.5 on the x-axis. That's 2.5 seconds, and the height is 106 feet. Okay. Now that's all there is to it. You just go ahead and use the maximum feature. Let's go through that again. Okay. Second calc, maximum. Going to move the cursor to the left of the vertex. Move it to the right, hit enter, Move it to the right of the vertex, hit enter again. Guess, just skip it and go enter one more time. And there it is. Now you'll notice that our number changed again. It's 2.4999998. And that's again, it's indicating all those nines is telling me my calculator was looking for the magical spot there, and it found very close to it. It's making calculations as it's walking across here, and it's looking for that spot. So just bear in mind that if you see a whole series of nines or a whole series of zeros and then a number at the end, it's probably just a number that's exactly the rounded version of that. So that's all there is to finding the max. And the same way would be to find the minimum. You'd go second, calc, and then you'd hit number 3 for the minimum. Okay, so that's how to find the max and min. You could do this with your pencil, but it's much easier to do with a calculator. All right, now let's take the same function and let's find the zeros. Well, let's go ahead and talk about that first. All right, let's take a look at the same problem, and let's say they were asking us, okay, when did that object reach the ground again? Right over here. Where did that reach the ground? Actually, we're going to get an answer back here too, right there, because the ground is when y equals 0. So again, we're finding zeros here because it's when y equals 0. So I'm going to get an answer here, but that answer is not going to mean anything because it's back in time. You know, the time's going this way, and as time advances into the future, when is that it's going to hit the ground again? So we're going to use the 0 feature of our calculator to do that. So here's your calculator, same function again, and if we're going to find those spots where it reaches, where it meets the y-axis, or excuse me, the x-axis, that's where y is equal to 0. I'm going to move this up a little bit so that I can see the bottom a little better. So I'm going to change my window, the y minimum, to say -20. I want to go up just a little. There, I've gone up a little bit. Now I can see the bottom just a little bit better. Also, I don't need quite as much to the right there, so I'm going to change my x maximum to go a little bit smaller. Maybe x is equal to 6 or something like that. There you go. Now you can see the spots where it crosses the x-axis. And we're going to find that using the same button, the trace button here. We're going to go second, calc. And if you look on here, you'll see one that says 0, number 2. Number 2 is 0, so I'm going to hit 0. And we're going to do the same thing we did before. Now we've got to do both of these. The one back here is unimportant, but let's practice on it anyway. So I'm going to take my cursor and move it. It says left bound. So I'm going to take my cursor just to the left of the crossing, right there, okay? And now I'm to the left of the crossing, enter. Now move the cursor just to the right of the crossing, enter. Guess, and enter again. And there is a 0. According to this, it's at -0.074, let's call it, and the y value is 0. Well, that's right, the y value is supposed to be 0 there, and this is in the negative, which is what I suspected because it's left of the y of 0, 0. So this one is an extraneous answer. We don't need it extraneous because it's going back in time. Okay. Now let's do the other one. Same situation. Here we go. Second, calc, 0, number 2. Move the cursor just to the left of the other crossing. So I'm moving it over there. Doesn't have to be real close, but there you go, just to the left of that crossing. Now, left bound, hit enter. Move it now to the right side of that crossing. Hit enter again, and hit enter one more time. And there's your other ordered pair. Now you'll notice something interesting happened here. On the y value, it says 1 times e to the -11. Well, that's scientific notation, and we're going to talk about that in a minute. But over here for x, it's 5.074. And that is a 0. That's where the zero, where the y value is 0. And so 5 seconds after you shoot it off, 1, 2, 3, 4, 5, the object hits the ground again. Okay? So why is it showing up that way? Well, let's talk about that. 1 times e to the negative 11. This is scientific notation. I'll put a times in there. Well, what does that mean? Well, negative 11 power means that this is a very small decimal value. So if I had, oh, I don't know, 10 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is, 1 times 10 to the 11th power. See this number? It is so tiny. It is actually, this is really equal to 0. So once again, your calculator is looking for this spot. It's looking for that spot, and as it's going across there, it's trying to calculate it, and it got real close to it, but it didn't get right at 0. Sometimes it'll show 0, and sometimes it won't. But because it was a decimal value here on the thing, it didn't really quite get right at 0, but that's in all essence is really 0. So don't let that number that's down there confuse you. It's a tiny, tiny decimal value, which means it's really just 0. This is kind of one of the quirks of working with the calculator. It's making calculations at lightning speed, and it's making them periodically, and so when it finds what it wants, it may not be right on 0. Okay, it may not be perfectly at the top of the parabola or whatever. Okay, so that's how you find the zeros. So we found the max, the min, and the zeros, and remember we are in the second calc feature. Okay, that's where you find second calc. Okay, that's where you find max, min, and zeros. All right, let's move to the next topic here. All right, we are going to make a scatter plot similar to what you see on the pictures there. This is page 300 in your book, and you're going to need to go there to pull this data from the table. I'm not going to take the minute right now to go over this while we're sitting here, but you're going to need to go and put this data in, where time is x and the water level is y. I'm going to have you go put that data in the table, and then I'll meet you at the other side. This is on page 300. We're going to put this in the table. Let me show you how I did it, okay? All right, let's set this up to put some data in your calculator. Let's review a couple things that we talked about back in chapter 2, but this is also on that help sheet that you can print from Canvas. Okay. First of all, go into your y equals screen and make sure there's no equations in there. Just go to those and clear them. Also, if we're going to plot data, you're going to have to turn plot 1 on. So I'm going to move up to plot 1 and hit enter. If I don't hit that plot 1, the data will not plot. So for now, I'm just going to leave this off just so you can see what will happen. I forgot to turn the plot on, let's pretend, okay? Now, we're going to go ahead and put this data in stat right here, right down at the bottom. So I'm going to go stat, edit, number 1 edit. And I went ahead and put this data in list 1 and list 2. Now, if you don't have list 1 and list 2, you can use any other list, but we're going to have to show you how to make sure that those lists are plotted. I went ahead and went up to list 1 and hit clear, enter. Do not hit delete, or you will lose those list names. List 1, list 2, list 3. Those list names will be gone. So you're going to hit list 1 and clear, and then you can enter all the data in there. Okay. So I put all of the data that's shown on page 300. I put it all in here, and you can see all of that data is appearing here. Now let me just make a quick note about this. Number 1, if you get to the bottom here and they don't match, every x doesn't have a y, you're going to get an error message. Every x has to have a y. So when you get to the bottom, double check to make sure that every x has a y and every y has an x. Also, extremely important, make sure that your data that you've inputted is accurate. Now, I didn't go through here yet and check all those numbers, but I would do that. I'd go through and check all of my numbers, make sure that everybody's exactly what they're supposed to be. One simple number error here will completely change your answer, and you could move from getting an A on something to getting an F. One simple number is all it takes. And this, I guess, kind of underscores the importance of the accuracy to which we do things in life. It's very important that even one digit can mess you up. Just like one character that's wrong on an email will get a bounce back, and that email won't be delivered. So every number has to be perfect. Double check it. I would say even triple check it to make sure your data is all correct. Now, I'm ready to plot this data. And so I'm going to hit graph. Let's see what happens here. I got nothing. It didn't graph anything. Well, there could be a couple problems. One, it could be that the screen is too small, and it could be that that I didn't turn on my plot. That would be the first thing I'd check. So I'm going to go to the y equals screen and look up there and go, oh yeah, I got to turn the plot on. So I'm going to turn that on. Now it's on, and let's hit graph again. Okay. Well, I've got one dot there now, and that makes sense because that first dot is at 42.6. So if I hit zoom standard, it probably wouldn't appear at all. Let's hit zoom standard, and that dot doesn't appear at all because 042.6 is way up there. So how do I get this data on the screen? Well, maybe you recall that the best thing to hit is zoom stat. So I hit zoom stat. I'm going to go down here to zoom stat, and I hit zoom stat, and there's all my data. It's a parabola. It's opening up. Okay, the parabola is opening up. Okay, now it looks like we got all the data there. I've got what, 5, 10, 12 points. Have I got 12 points on here? Probably do. Now, part of the problem with this is that I may not be looking at my X and Y axis, and I want to be able to do that. So I'm going to change my window settings here. Zoom Fit will plot all the data, but it won't necessarily get a good picture where your X and Y axis are appearing. So I'm going to go to Window, and I'm going to set it up so my X minimum is just a little bit to the left of the Y axis, and my Y minimum is a little bit left of the X axis. So it's got 27 here. That tells me that I'm not seeing the X axis. So I'm going to put a small number like -2 in there. Now I should be able to see, let's go ahead and hit graph, I should be able to see both X and Y axis. Okay, the one at the bottom looks a little funny. So that means my scale is a little bit off. So we need to adjust the scale. So let's go to Window here. Now you'll notice that the X data went by 20s, and that would be a good thing to make my X scale. So let's make the X scale go by 20s. And the Y data, it goes from 42 all the way down to 30. I probably should make my Y scale go by maybe 2s instead of going by 3s. We're going by 1s. Let's go by 2s. That'll give me about 15 spots. So let's graph that. All right, that makes more sense now. We've got a picture here. We're on the left. My y-axis is going by 2s, and on the bottom here, my x-axis is going by 20s. So there's a pretty good graph right now. Okay. So now you've plotted your data. You want to practice this a lot. The window is the challenge where you have to try to set this up so you can see everything you want to see. I always put if I want to see the X and Y axis, I just go to the left of those or below those a little bit using a negative number of some kind. Okay, so there's your graph, and you can see all the data that's plotted there. All right, now this data looks like it's forming a parabola, but what we're going to do is we're going to find a curve of best fit. A curve of best fit. You know, I'm going to go up a little bit because I don't like this thing crowding at the top. So I'm going to change my window. I'm going to change my window, and let's go to the Y max a little higher. Let's go up to 50 just to make it a little bit higher. Okay. Yeah, let's come down. Let's do it a little bit farther. Let's go up to y. Let's go up to maybe y80. Y max is 80. So the y is up at the top. Okay, y max would be like 80. There we go. It's not quite so crowding the top of my screen. Okay, my tick marks over here have gotten too small though, but that's okay. All right, now we're going to try to plot a quadratic regression, and you can see how this is done in your book. The steps are there. It's also on the sheet that I left you on Canvas. But we're going to go ahead and calculate the curve of best fit. What we're going to use is in the stat menu now. So I'm going stat, calc. We'll arrow over to calc. And the one that we want today is 5, quadratic regression. And if you look at number 4, that's one we've used in the past, the linear regression. Well, we're not going to use a line. We're going to use something that's going to calculate a quadratic regression here. So I'm going to use that. And then it asks me for my 2 lists here. Now your calculator may look different than this. It may just give you calc quad, or it might say quad regression or something there. You'll have to type in the 2 lists that you have. And so let's pretend that you got a different list there. I'm going to change this. The lists are found on the bottom. They're in blue. Let's say I want to type in list 5 and list 6. I'll go second 5, put a comma. The comma's right here above. Comma's right here. Okay. Actually, I don't need one on this. And then I go down to the other one. And let's say I want to put list 6 in here. So I'm going to go second list 6. Okay. So I've got my 2 lists there. List 5 and list 6. Okay. There is instructions on the sheets on how to rewrite all the lists if some of the lists are gone. You'll have to get rid of them all and start again by typing in list 1 and list 2 at the top of your stat. So let's say we went in here and some of these lists were wrong. I could go up to the top and get rid of all of those lists by hitting delete, and then start all over and start with list 1. So second 1, move it over, second 2. So those instructions are in that sheet if you need them. Okay, let's go back to our main work screen here. Let's go let's go stat, calc again, number 5, quadratic regression. And let's change that back to the 2 lists that I want. I got second 1, comma. If I was in the other calculator, I'd put a comma there. Second 2, and then the calculator then will in this calculator it says calculate. I'm going to do this again in the other calculator so you can see it. Okay, and calculate, and it will calculate a bunch of numbers for me. Now notice at the top you'll see that this is the quadratic regression. Okay. And it's got A, B, and C. And there they are. You can see that this number's really tiny. It says e to the negative 4. What is that number? Well, that means my decimal's been moved over. This is 0.00021. That would be e to the negative 4 means I moved it over 4. 1, 2, 3, 4. So there's A value. There's your A value. And B is a negative 0.1034, and C is 42.6541. Now on the test, I'm going to ask you to give me these decimals to 4 decimal places to retain the accuracy of the problem. At the bottom, you're going to see an R squared factor, and what that simply means is how closely does the data fit the graph. We're not going to talk about it here today. We've done it in the past. But this R factor is so close to 1, it's telling me that it's a very good fit. Very good fit. Okay. So now I'm going to jot these numbers down here. And we're going to go ahead and put those in your y equals screen. Okay. Those are your numbers. We're going to put that in the y equals screen. All right. All right. So I've gone ahead and entered that data in here, remember it's ax squared plus bx plus c. So here's a, 0.002x squared. Bx would be negative 0.1034x. And then c is out here at the end. It's kind of run off the end of my calculator here, but 42.6541. There is your curve. Make sure you enter it accurately. If you make an error here again, everything's kind of messed up after this. Okay. So let's hit graph. And now it's drawing that curve on my calculator. Okay. So there is the parabola, and it's been graphed in there, and we have the equation for this particular function. Okay. So that's how you find it, and I suggest you go through this a couple times to make sure you're doing it correctly. Find the linear, the quadratic regression. All right, I'm looking at the TI-83, not the CE calculator, and I want to show you that there's just a couple slight differences here. Okay. Let's say I want to go ahead and calculate this curve of best fit. I'm going to hit stat. Stat, calc. That hasn't changed. And number 5, quadratic regression. That hasn't changed either. But you notice that this window doesn't have a full array of a list there. And so if yours is like that and it doesn't have the lists already in there, you're going to need to put them in. And I'm going to hit second 1, which gives me list 1, and then hit the comma button, and then second 2. And maybe you've got different lists that you're using. You can type those in there. But list 1 and list 2 are the two lists that you're going to need. Now I've got different data in here, but when I hit enter, it's going to go ahead and calculate those A, B, and C values. It's just got different data because I'm using a different calculator here. But once again, you can use second 1. You've got to put a comma between them. Let's do that again. Stat, calc. Whoops, it's the wrong one here. Let's start again. Stat, calc. Number 5, quadratic regression. List 1. So second 1, comma, second 2. And I hit it, and I get this equation. And I jot all those numbers down so I can enter them. Make sure you jot them down, round it to 4 decimal points properly. So that's the main difference between these two calculators. You can play with it a little bit, but you'll recognize that list 1 and list 2 are the two lists that I had to use there. All right, now once you've got your curve there, the problem's going to ask you for the vertex or zeros or anything like that. This particular problem, I think it probably doesn't, it might not even cross the x-axis, so it has no zeros, but we can find the vertex on this. But I'm going to move my screen over to the right a little bit, so I'm going to change my Windows setting X value to go over to, say, 400. I want to be able to see all the way to the right here. Yeah, see, now it's coming back up. So I can see that there is a vertex, in fact, right in the center here somewhere. So we're going to find that vertex using the same approach that we did before. So here we go. Second calc, minimum, because this is at the bottom. Left bound, we're going to go a little left of the vertex, enter. Right bound, go a little bit to the right of the vertex. I'm not sure where it is, but I want to get over here far enough. That's probably far enough. Enter. Guess, hit enter again. And there's your vertex right at the bottom. Okay? 258.5 and 29.3. And you would jot that down. So this will allow you to find the vertex. And you can do the same thing with zeros. Okay? So if I wanted to find there aren't any real zeros on this problem. So if I went to second calc and hit 0 on this, it will give me the options of setting all this up, but I can see from my parabola that it's moving away from the x-axis, so there are no zeros here. All right, so that's how to do how to make a curve of best fit using data, and then you may have to find zeros, or you may have to find the minimum or the maximum. Let me show you one other thing that may happen. All right, there are two things we're going to take a look at here. Sometimes they're going to ask you to find the y value if x is equal to something, let's say 0 here, or find x if y is equal to 135. Let's start with the first one. Finding y when x is 0 is pretty easy. We're going to use the value feature. So let's take a look at where. All right, we've done this before. I want to show you again. If I want to find a y value when x is equal to something else, I'm going to hit calc, second calc here, and number 1 is value, and it will flash a cursor at the bottom of your screen and let you put in the value you want. Put in the value that you wish to put in. Okay. Now you can put in any value you want to. Let's put in 0 and see what the value is. You'll notice that the cursor is now blinking right where we put 0 in, and the value is 42.654, and that's the value on the curve, not the data that you put in. So you can find it at any spot. Let's say we wanted to find where x is equal to, oh, I don't know, something out in the future, say 300. So second calc, if x is 300, let's just put something out in the future and see what we get. Notice the cursor is now blinking out there. If x is 300, y is 29.6. It allows us to find any data in time out in the future or even into the past just by plugging in that value. Okay? Now the other problem on how to find x when you know y, there's two ways to solve that. Let's take a look. All right, the second problem we're going to tackle here is how to find x if y is 135. Well, if y is 135, here's your equation over here. And if we, instead of letting this equal to 0, we let it equal to 135, then the equation is equal to 135 at that point. I could subtract 135 from both sides, and then now it's set equal to 0, and now I could use the 0 feature to solve this. Okay, if I go ahead and use 0 feature, I can solve this if I subtracted 135 from both sides. So that's one thing you can do, is simply subtract 135, because if it's equal to, this is y is equal to 135, I can just set this equal to 0 and then solve it that way. The other way we can do that is simply to draw a horizontal line. Let me show you that. Alright, here's that same parabola that we just had in here, but I've moved my windows over and up a little bit to accommodate this problem. If my goal is to find the x value when y is 135, I can create a horizontal line here that's at 135 and just see where they cross. Let's see how you do that. So I'm going to go to y equals screen, and on the next y2 I'm going to put in 135, and that's going to create a horizontal line right there. Let's do it. There it is. So the red line is showing you where the y value is 135, so the x value would have to be at the intersection of those two spots. So what we're going to do is we're going to use the intersect feature, and you've used this back in working with systems. So second calc, intersect number 5. Okay, so go down to number 5, intersect, and now it's going to ask me those same questions. First curve, and if you look at the top, yes, that's the first curve we want. Second curve, yeah, that's that second one. And then hit enter and enter again, and I get this intersect. So I can see that 135, the y value is 135, the x value would be 985.5. It'll help me find that spot. This is some ways way easier than doing the algebra the other way. Not hard, but you can just go ahead and draw a horizontal line. So when do we use this? We use this when we know a y and we want to find an x. So let's look at that again. I know a y is going to be 135. What do I use then? I'm going to put that in and make a horizontal line. And then where these two intersect is that spot. Let's do it again. Second calc, intersect number 5. First curve, yes. Let's see, move this off so you can see that I'm doing it. First curve, yes. Second curve, enter, yes. Guess, enter. There it is again, okay? So I'm using the intersect feature to find when y is 135, what would x be? So I'm looking at the 130, y is 135 and x is 985, okay? All right, let's look at the last question in our exploration today, okay? All right, let's take a look at this one. You won't see it just yet, but there are problems where the zeros are not real. Let's put this in our calculator and see what the graph looks like, okay? Actually, I've got the wrong equation here. It should be plus 13. I'll redo that again. X squared minus 4x plus 13. All right, I've stuck that in the calculator now. And we're going to go ahead and graph, and I'm going to just use a standard window to try graphing this. So zoom standard and see what happens. Can't see much, but I do see a little bit at the top here. I'm going to have to go up some. So let's go up a little bit and see if we can see the top of this graph a little bit better, just to see it. Window, I'm going to go Y max a little bit bigger. Let's go up to say 20. Look at it again. Yeah, there's my parabola now. All right, what if this question asks you to find the zeros? Well, you know that the zeros, or the roots, or the x-intercepts, or the solutions, they're where it crosses the x-axis. And you can see in this problem, this parabola is never going to cross the x-axis. So this does not have any real roots. But it does have complex or imaginary roots. It has imaginary roots. So you can't actually use the second calc zero feature here. Watch what happens here. I'm going to put in zeros and I think, well, how do I get this to cross over the x-axis? Well, I can't. I can't get it to cross over the x-axis. So this is not going to be possible. And you're going to get an answer like this. It's going to say, check for valid bounds. It's going to give you an error message of some kind. Well, that's obvious here because this does not cross the x-axis. So we cannot use the calculator screen to actually find these roots. They are going to be imaginary. So we're going to have to use the quadratic formula. Now, if you recall, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And just a reminder that as you're using the quadratic formula, you've got to keep in the calculator, you've got to keep this in parentheses, and you'd have to keep this in parentheses. Make sure when you plug things in that you're doing that. Now, there are going to be 2 answers here, and the good news is that complex roots always come in conjugate pairs. So you're only going to have to make one calculation, and notice if you get the positive one, the other one would be the negative version of it. So we're going to go ahead and plug this in your calculator and see what comes up. Okay? All right, now before we put this in the quadratic equation, we're going to have to put that in your work screen. We have to make sure this calculator is set up to understand imaginary numbers. So I'm going to go to mode. That's right here, mode. And I'm going to look down here to see if it's set up for imaginary or real mode. Look down here where it says real. I don't want real here. I want a plus bi, which is what we call complex mode. So make sure it's set for a plus bi. Go to real, and then right next to it's probably a plus bi. Now the thing is set up to put this in an imaginary answer. All right, we're going to go to the main work screen, so second quit. Don't try to do this in your y equals screen. And we're going to plug in those values. So here we go. I'm starting with a parentheses. Negative b, well, that's a negative 4 or positive 4. Here's our equation. I guess we should go ahead and move it up a little bit. All right. negative 4 plus or minus, for now let's just put a plus sign in here, square root of b squared. Well, I'm going to do this in my head. Negative 4 squared is a positive 16 minus 4 times a is 1, times c, which is 13. And I'm going to get out from underneath the radical. Got to get out from underneath it. Don't try to hit parentheses yet. Then put your parentheses. To get out from the radical, use the arrow there. So there it is. Negative b plus the square root of b squared minus 4 times a times c. All over, that would be divide, 2 times a. Now I don't have to do this, but I'm just for the emphasis, I'm going to put a parentheses here. 2 times a would be 2 times 1. Normally I would just divide by 2 and avoid all those extra things I put in there. And I'm going to get 2 answers here. Or I'm going to get one, actually, one answer. And there it is, 2 plus 3i. You'll notice the answer is given to me now as a compound number. A complex number. It's got the real part and the imaginary part. It's telling us that there are no real zeros. There are two complex numbers. Now that's one of them. The other one I know is minus because they always come in conjugate pairs. But let's prove it. So I'm going to re-enter this by using the second entry feature. And it pulls up the old problem and it's now live. And I'm going to go over here where it says plus sign and I'm going to just subtract and hit enter again. And you'll notice that I got the other answer, which is what I expected. They came in conjugate pairs. In order to find the zeros of a function that never crosses the x-axis, you're going to have to use the quadratic formula to do that. So make sure you know how to plug it in with enough parentheses. You got to know the formula from memory. You can't come here without the formula in your head. And there is that formula again. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Make sure that you're using parentheses on the top and parentheses on the bottom. Your calculator will not understand it if you don't do that. Okay? So that's how to find those complex roots when there are no real roots. And again, the reason there are no real roots is because the parabola does not cross the x-axis. All right, so that's what you're going to need. You may need to watch this a couple times to see what's going on here. It's a long video. And we're going to practice a couple days on the same stuff. You can make up problems yourself here. Okay? All right, you're going to be left with a lot of freedom on this assignment. You may do some of the problems on page 341. Take problems in there where you're going to find the max and the min and zeros. Okay, just take some problems and practice finding the max, the min, and the zeros. Of course, the max and the min are those vertices, right? Then you can go back to page 300 and do that problem again, or make up your own tables. Make up some tables of data that look like parabolas. You just make something up, you know. 1, 2, 3, 4, and you just make up some numbers that go up or down or whatever, and see if you can plot a data and a curve of best fit. Make up your own, and then calculate the max or the min or the zeros, okay, and also use the value feature in there as well. So just practice this stuff. You may have to look at this video a couple times and practice that. So have fun with this. You're going to spend a couple days on this, and the test on this is going to be coming up shortly on Tuesday, June the 2nd. So this is the only teaching assignment I'm going to give you on this. You're kind of on your own to kind of watch this video numerous times. It's a long video, but watch it a couple times and use the worksheet that I gave you, the sheet which has all right.